Hello everyone, my name is Grant Shipley and I'm a Senior Manager of Product Marketing on the OpenShift team. In this tutorial, I'm going to show you how to use OpenShift Enterprise to deploy applications out to your own private cloud. I have OpenShift Enterprise installed on my own private server. It is a fresh install, and I'm going to show you how to utilize it in a couple different ways. Let's start with the web console. So I'm going to open up a web browser, and I'm going to confirm the security certificate, and then you'll see that it's asking me to authenticate. We support different authentication mechanisms for OpenShift Enterprise. At this point, I just have it set up for basic auth, so I'm going to go ahead and authenticate to OpenShift and click Login, and it's going to drop me on the OpenShift Web Administration console. At this point, I can view any current running applications that I have by clicking on My Applications. You'll notice that I do not have any applications since this is a fresh enterprise install, so it's going to drop me on the Create Application screen. At this point, I can create an application based on my currently installed cartridges. Right now we're going to use the existing cartridges that I have installed, and then a little bit later in the tutorial I'll show you how to install a new cartridge. So let's start with the PHP 5.3 cartridge. I'll select that, and it's going to ask me for my application name, and it's going to display the namespace. Now I've already created a namespace for my account, and I just decided to call my namespace private. So let's create an application called PHP test, and I'll click on Create Application. What's actually happening at this point is it's setting up the gear, which is just a container to house your application code. It's going to make sure that all the configuration and security parameters and configuration are installed and properly configured. And it's also going to make sure that Apache and ModPHP are installed and ready to go for my application gear. You can see that it does provide a URL for me, and the URL structure is my application name dash my namespace and then my domain name. For this tutorial I'm just using example.com. Now in order for this application to actually work for this tutorial, you'll notice if I click on this I'm going to get a cannot find server, and that's because I don't have DNS set up to propagate correctly. So the way I'm going to fix that is I'm just going to edit my host file, and I'm going to add my server IP address, and then we called this application PHP test, and I'm going to save that. So now if we go back to our web browser and refresh that page, you can see that very quickly my PHP application was set up and a default template was deployed. So a lot actually just happened behind the scenes here, but this does allow developers to create an application very quickly without having to worry about setting up virtual machines, configuring firewalls, databases, and whatnot. So now that we have this application created, let's dig down just a little bit further, and we notice that in order to make code changes I need to set my public key. So I am actually going to go back to the command line, and I'm going to go into my .ssh directory, and I'm just going to look at my public RSA key, and I'm going to cut and paste the contents of this up to my OpenShift Enterprise server. Now that I have my public key created, I can go ahead and git clone this application, because that's one of the things that happened when we created the application, is it did create a private Git repository for me on my actual gear itself to house all of my application code. And that's how developers will interact with OpenShift Enterprise and with OpenShift Online, is via Git. The one area where users would not want to interact directly with Git and source code is if they're deploying Java-based applications. We do support the ability to deploy web archives or WAR files or EAR files, enterprise archives, for the JBoss application server. So let's go ahead and make a change to that quick application we created. I'm going to git clone this application down to my local machine. So I'm going to go to my home directory, and I'm going to make a directory called Enterprise, and in that directory I'm going to issue the git clone command that will make a copy of my repository and pull it down locally. And it's going to ask me to add that key or that host to my known host file the first time that I run that, and that's the only time I'll have to do that. And pretty quickly it was able to git clone that repository, and inside of the enterprise directory that I just created, If I do a ls, I'll have a PHP test directory now, which is where my application code is contained. Let's examine this directory real quick. First thing we'll see is a README file, and this will be helpful to developers because it explains all of the directory layouts for the application. A couple things to note here. Let me just clear my screen and get a fresh look here. We have the README file, which we just looked at. We have the deplist.txt file. That is where PHP developers can include any third-party dependencies that they may have for their application, whether that's a pair or a PECL module. They could just drop the pair module name directly inside of that deplist.txt, and then when they deploy their application code or git push their application code, it will resolve those dependencies and download the required pair modules. The libs directory is where users can provide their own private PHP libraries or classes that they want to have running for their application. And then the main application source code is actually in the PHP directory. So the PHP directory is actually the HTTP document root for this PHP installation. If we do a listing of all, we can see that we also have a .OpenShift directory. Inside of the .OpenShift directory, we have an action hooks directory. This will allow developers to develop an action hooks script based on several different hooks that can be used, whether that's a pre-deploy or a post-deploy. They can write a script or basically any executable that can be ran on the Linux file system itself to execute once that hook has been enabled. So for instance, maybe every time I deploy a new version of my PHP application out there, let's say for instance it's actually a WordPress intranet, I can write a shell script or something that anytime I deploy a new version, that it emails the company to let them know that the new version of the intranet is now live. Or maybe they just want to update an RPM version number if they're deploying out or something. So it's pretty flexible. We also have a cron directory. If you cd into the cron directory, you can actually set up scheduled jobs and drop them in the correct directory, whether you want them run daily, hourly, every minute, monthly, or weekly. And again, that is just a shell script or an executable that can be ran on the Linux command line. And then if I put something in the minutely directory, every minute on the OpenShift Enterprise server that this gear is running on, that script will get executed and perform those actions. The markers directory is kind of interesting. That's where you can specify to hot deploy your application. By default, we actually stop the application server. In this case, it would be Apache. We push your source code out, and then we restart Apache and run all of the action hooks again. You can actually set a hot deploy marker inside of the markers directory that will tell OpenShift Enterprise to not restart Apache on every code push. Let's go ahead and make a change to our code. So I'm going to cd into the PHP directory. I'll do a long listing here. And you can see that we actually have two files by default for a PHP application. We have the health_check.php file and the index.php file. So let's actually look at the health check PHP file. And we can see that that just returns 1. Let's actually vi the health.php file, and you can see that it does just print 1. And you could use that health check or something as a Nagios plugin or a web page that Nagios could hit in order to determine if your application is actually up and running. So let's actually add a new file. We'll call this test.php, and I will write some PHP code here. We'll say hello OpenShift Enterprise. Nice to meet you. And I'm going to save this file. And then because OpenShift uses Git, which I've talked about before, the first thing I want to do is add this file to my local repository. Now that the file has been added to my local repository, I'm going to commit that to my local repository. So notice I have added the file and I've committed it, but that has not been pushed up to the OpenShift server yet. And that's because Git is a distributed revision control system, and all of the changes that I've made so far are on my local machine. So we can see that sure enough, if I go out to my OpenShift Enterprise server, test.php is not a valid URL, and I get a 404 response. To actually push this test.php file up to the server, I need to run what's called a git push. And this basically takes all of the source code that I have in my local Git repository, and it pushes it up to my origin server. That's a Git terminology for my main Git server. In this case, it's a remote server on the OpenShift Enterprise server that I have set up and installed and configured. So I'm going to run git push on that. And we can see a lot of things happening here. So I'm just going to walk through this real quick. First thing it did is it compressed the files, and this is just part of Git, and then it wrote those files. And then you can see everything that happens on the remote OpenShift Enterprise server is prepended by the remote colon. So we can see what it's doing here. It stopped Apache. It's done with that. And then it's running all of the action hooks. You can see that it ran the pre-build, build, and deploy action hooks, which are just empty. It's checking to see if I have that hot deploy marker added, which we talked about, and I do not, so that's false. And then it's done, and then it's going to run the post deploy hook. So let's go back to our web server or our web browser and make sure that that actually got deployed, and in fact it did. So as you can see, we quickly, just over a couple of minutes there, set up a brand new PHP server, and we made a change and we pushed a change out live to our gear that's running on OpenShift Enterprise. So let's go back to the web console, and I'm going to click on My Applications, and we can see that we have the PHP test application. So I'll click on that, and we can do a couple of interesting things here. We can add a cartridge. Now in OpenShift, we think of cartridges as things that are going to change the state of the application. If you think back to the Nintendo Entertainment System that we played as kids, it had a cartridging mechanism, and it changed the state of the console. And so with a cartridge, it allows you to change the state of your application and to add more features into it. We do have a cartridge API, so users can develop their own custom cartridges to embed in their applications. So right off the bat here, we could enable Jenkins build if this was a Java application, or we could even use it for PHP to maybe run our test automation framework. So I'm going to click on Add a Cartridge, and we can see the cartridges that I have available to add on my OpenShift Enterprise installation. I have MySQL 5.1, Postgres 8.4. I can embed the cron tab cartridge, which I explained the directory structure for that, or I could embed a Jenkins client for this application. Let's go ahead and select MySQL. So I'll select that, and I'll click on to add that cartridge. And what's actually happening now is it's creating a private MySQL database just for my application. You can see that happened really quickly, and it gave me the root user for that MySQL database as well as the password, and it created a default database for us based on my application name. So at this point, I can connect to that MySQL database and begin executing commands around that database. So let's go back to the console, and I want to show you one other neat thing that you can do. You can actually SSH in to your OpenShift Enterprise gear. Now I'm SSH'd in based on my unique user ID that was created for this specific gear, and it's this information right here. And then I SSH to my host, which is phptest-private.example.com. Now, if you don't remember, the way this is resolving is I actually added an entry in my Etsy host file on my local machine to resolve this to the correct IP address. Now in a typical customer environment, they would be hooked into their existing DNS server, and that step would not be required. So now I'm sitting on my OpenShift gear, and I am jailed here. It is a jailed environment based on SE Linux and Linux control groups. And I can do a couple different things here. If I wanted to SSH into my machine, I can look at my source code, but I can also run the MySQL prompt. And you can see that I didn't have to authenticate to MySQL or to the gear. So how does that happen? We Initially, if you remember in the web console, I uploaded my public SSH key, and that's how we handle authentication with OpenShift Enterprise. So when I SSH'd in based off of that unique UID or user ID, it used my local private SSH key to authenticate me. Now, why didn't I have to authenticate to MySQL? If we actually do an env grep OpenShift, OpenShift actually sets environment variables for a user's workspace. So let's narrow this down a little bit. Instead of grepping for OpenShift, let's grep for MySQL. I'll clear the screen and run that again so you can get a better view of it. You can see that we do set environment variables for the user. We see that we set the MySQL DB port to the default MySQL port of 3306, and we also set the DB host to the new IP address of my private MySQL instance, as well as the password. And so when I type MySQL, we're actually passing that information in, so I'm authenticated as that user. And at this point, I can use MySQL just like I normally would, and we see that I do have a PHP test database that was created for me by default, but because I am the root user at this point, I can create a new database and name it anything I want, like PHP test 2. And now if I show databases, we have a PHP test and a PHP test 2. I can use PHP test, and just to show you that I do have full access at this point to control this schema, let's just create a quick table. We'll say create table users. We'll say this is a user ID, it's an N and it's not null, and maybe we have a username that's a varchar 200. And now I have that table created. Then I can insert into users, maybe it's 1 and gshipley@redhat.com. I didn't type something correctly here. There we go. So now if I select asterisk from users, we can see that I've created that database and that table, that schema, that initial schema creation. At this point, because I do have access to MySQL, in PHP code I would just include the the MySQL libraries that I want to use. We provide those by default, and then I can begin executing queries against my database. So I'm going to exit out of MySQL and go back to the browser real quick and just show you a few other things that you can do here. We give pretty good instructions here on the Enterprise console to allow users to start and stop their databases as well as their application. So maybe they wanted to load a bunch of data into MySQL and then restart it or something. They can do that. You can also remove cartridges from your application. And lastly, if you go back to My Applications, click on PHP Test, you can delete the application by clicking on this button. You can also add aliases, which will basically be a CNAME record to this application. So maybe in a production environment they wanted to use www.redhat.com because it was their main website for their company. They could create just an alias inside of this for their main website so they don't have to reference it by this internal OpenShift Enterprise domain name. So that's the basics of the web console. You can also see how many gears you're currently using and if the gear is shared or not with your database. So now let's do all of that quickly on the command line just to show how users can interact with OpenShift Enterprise via the command line. So I'm going to go ahead and create a new PHP application. I'm going to say RHC app create, and let's actually create a WordPress application. So I'll say -A WordPress is what I'm going to call it, and we're going to use the PHP 5.3 application type, and I'm going to authenticate, and it's going to create a new gear for me just like we did on the web console, except this time we're using the command line tools, and it's going to use my default gear size, and it's going to put it in my namespace and set up a private Git repository for me. One nice thing about OpenShift is that if you go out to github.com/OpenShift, we have what we call quick starts. I'm looking at the WordPress quick start now. So we've basically taken a ton of the most popular open source applications out there, and we've created quick starts for them so users can get up and running very quickly with WordPress or Drupal or Liferay or Redmine or whatever the specific OpenShift project is for WordPress. So the next thing we need to do is actually embed a MySQL cartridge into this via the command line. So I'm going to say rhc app cartridge add. I'm going to pass in my application name, which is WordPress, and then -c and pass in the cartridge name, which is MySQL 5.1. And I'll go ahead and authenticate. And it's going to add a WordPress database for me and provide me the connection URL for that. So you can see that that was all done successfully. So I'll clear my screen, and now let's go embed the actual WordPress source code into our application. So what I'm going to do is just add a remote Git repository, and this would be a very popular use case for people in order to get up and running with open source projects or to get up and running with their existing source code repositories. So I'm going to add that remote Git repository, and I'm going to pull all of that WordPress source code locally. And this will actually overwrite everything that I have in my WordPress directory. So I'll add a commit here. And so now in my WordPress directory, if I go into the PHP directory, that sample stock application has actually been replaced with the WordPress source code. So now all we need to do is push this code up to our OpenShift Enterprise gear that we created, that we named WordPress, and we should have a WordPress installation up and running in a couple minutes or so. So it's going through all of the action hooks and starting and stopping Apache at this point. And it should be done in just a second. And at this point it found the database server, and now it's going to import the schema for WordPress. So now if we go back to our web browser and we go to wordpress-private.example.com, we can see that just over a couple minutes we created a new application gear, created an application called WordPress. We added a MySQL database, and we pulled down the very popular open source WordPress content management and blogging software and deployed it on our gear. At this point we can log in, and the username and password is OpenShift or admin, and the password is OpenShift admin. So I'm just going to copy that, go back to the web browser and paste that in, click on login, and it's going to ask me to update my WordPress database. That's done, and at this point I am logged into my brand new WordPress instance as the administrator, and I can begin configuring it at this point. So that's quickly how you can use a quick start. So let's go back to the OpenShift console, click on create application, and I want to show you how to add new cartridges to OpenShift Enterprise. As we can see, we have JBoss EAP here, Perl, Python, PHP. Let's actually add a new cartridge. So to do that, you need to SSH into the machine and have root, and I'm already on that machine. And I'm going to list all the current cartridges that I have installed right now for OpenShift Enterprise. And we can see that we have the Postgres cartridge, Perl, Jenkins, everything that we saw in the web UI. But I want to install a new cartridge, so I'm going to just yum search, and I'm going to search for cartridge. And we will be presented with a list of cartridges. We have JBoss EWS, we have Ruby. So let's actually install a Ruby cartridge real quick, just by doing yum install and the cartridge name. So let's install a Ruby 1.8 cartridge, copy that, paste it in. It's going to resolve all of the dependencies. So this is where a customer could, if they created their own custom OpenShift cartridge and added it to their satellite server, whatever channels they have for their RPM repos, they could install custom cartridges that they've developed. So now that the new Ruby 1.8 cartridge has been installed, the only thing left to do is to clear the cache. So in order to clear the cache, I'm going to go into the var www OpenShift directory and go into the broker directory. And inside of here, you need to run the command rake temp clear, which will clear the cache. So that's done. So now if we go back to the web console and click on Create an Application, we should see the new Ruby cartridge available to us as a user of the application. And if I scroll down, sure enough, there it is. We see Ruby 1.8. So let's go ahead and create a quick Ruby test application just to ensure that all of that worked. So I'll create that application. It's following the same process that it did when it created the PHP applications previously in this tutorial. Now that our application has been created, we can see that we have ruby test-private.example.com, and then I would git clone that Ruby code and begin working just like I've showed you with the PHP files or the PHP application types. So that's the end of the tutorial. I hope you've enjoyed it and that you've learned how to use PHP and Ruby on OpenShift Enterprise, as well as to install your own cartridges that are not available by the default installation as you install OpenShift Enterprise. Thank you.